Okay, we've actually had a lot of preview into what we are doing today, which is the nice part of it. Today we're writing equations looking at pictures, but the thing that I'm going to change a little bit that we have not really done is we're going to have to include phase shifts in our equations, because I'm going to ask that you write each picture as both a sine and a cosine. One of those doesn't necessarily have to have a phase shift, but if we do it for both, one of them will have to, because they can't both start at the same spot. So when we're working through this part, before I go to that first page, we do need to think through, as we look at each picture, what are A, B, C, and D as we go to write our equations. So we're kind of going out of order as I attack this. And we will talk about A and D and B first, because that doesn't matter which way I write the equation. A, D, and B are the same, whether we write our equation as sine or cosine. And so you'll notice that on a lot of my work, I'll just have those listed out to the side, regardless of which one I'm doing, because it's the same for both. Okay, the amplitude does not change if it's a sine or a cosine. The vertical shift doesn't change if it's a sine or a cosine. So let's talk about these. The first thing that I will do when I'm trying to write the equation of a picture I'm looking at is a lot of times I'll just go and draw a midline for myself. And it helps me do two things. It helps me see the amplitude a little bit better, but it also like shows me exactly what the vertical shift is. So I would come here and you can visually find your midline. And if visually finding your midline is easy for you to do that. Okay. So where I drew that midline, what I need to do is make sure that it is evenly spaced above my maximum and my minimum. You do have formulas for these. If you are a formula person, you can do this, where we would identify our max and min values, where our maximum is up at 1 and our minimum is down at -5, and we would use those values in formulas if just looking at it is not going to work for you. So after I found my midline, first of all, that is our D value. Okay, so D is going to equal the location of the midline. And again, if doing it visually works for you, I would stick with that. So ours here would be -2. If you are a formula person, I would identify what my maximum and my minimum are. And your formula for finding D then would be your maximum plus your minimum divided by 2. The midline is the average of those two values. Well, our maximum is 1. I'll show you how this works here. Plus our minimum of -5 would be -4. And -4 divided by 2 is -2. That's exactly what we do our line. Okay. Then our amplitude, again, if I can look at my picture and identify my amplitude, that's kind of the route I take, but I'll give you a formula if you are a formula person. Our amplitude will be our distance, our max or our min is from the midline. Okay, so in our case, it looks like from here, my midline being at -2, my maximum is up at 1. That is a distance of 3. And I can just in a picture of how far that is. If you are a formula person, I don't love formulas, but these two look a lot alike. And the difference is going to be that it becomes our maximum minus our minimum. This finds the distance between your max and your min divided by 2. Well, our maximum minus our minimum would be 1 minus -5. 1 minus -5 is 6. 1 plus 5 is 6 divided by 2. You see that our amplitude in this one is 3. I like the visuals a lot better, but if you want the formulas, there you go. Question. Okay, now it doesn't matter if I'm looking at this picture in the frame of reference of a cosine or a sine, those will not change. They're now for both of my equations that I'm going to write. The next thing we're going to talk about is the period. And it doesn't matter if I count the period as a sine curve or a cosine curve, it applies to both. The period is the period for any graph that we want to write this as, any function that we want to write this as. So if you are able to start at the y-axis, that will always be the easiest method. So what I have done for us is kind of shown us the different things that could start at the y-axis. So if I look at this first one here, training my eyes on the y-axis, this graph starts on my midline. That would be my midline, right? Starts on my midline, which would be these two in this column right here. And if that is the case, I would be counting the distance of one full sine curve. To do that, I would go from my midline to a maximum, back to my midline, to a minimum, and must return to the midline. So here's what it would be: maximum, midline, minimum, midline, and when I have completed that, that is the period. Okay, now if it has down first instead of up first, that was a sine curve with an ROX, and you just do that backwards. I hit a minimum, then I go to a maximum, and I return to my midline. So midline, hit that minimum, go through my midline, back up to a maximum, return to my midline. When I completed that, I completed one sine curve. And again, this is if it is starting at the midline at my y-axis. So I hit minimum, maximum, finish my sine curve. That's what it takes to finish a sine curve, is you must hit both, a max and a min. And when I've done that, that tells me what the period is, again, in this case, 2 pi. Okay, so what if I look at my y-axis and instead it is at a max or a min? Then we are counting a cosine curve. So if I count a cosine curve, I must, if I start at a max, I must find the next max, max to max, okay? So in this example, we are starting at a maximum. To finish a cosine curve, I must get back to a maximum. That would again then tell me the period length of this graph. If I start at a minimum, again, we're counting a cosine curve that had an ROX, and I must return to where I started. Minimum to minimum would complete a full cosine curve. So I hit that max, return to a minimum. That is the length of the period. That's the normal ones. Those are the ones we see most often. You will either be able to identify a sine or a cosine curve that is starting at your y-axis. And it is always going to be easiest for you to count the period from the y-axis to ending whichever full graph you started. Okay? Every now and then, we don't have that option. Okay, what if at the y-axis we are not at the midline or at a max or min, like this picture? Okay, so in this picture, I look at the y-axis. The dot on my y-axis is not at my midline, so it's not starting a sine curve. It's also not at a maximum or a minimum, so it's not starting a cosine curve there. Nothing is starting there. And so what you need to do then on this one is you have to kind of step back. And I think the easiest thing is either to count from a max to a max or from a min to a min. Having a cosine curve is usually easier in this situation. So if we did that, here is a minimum. To finish this cosine curve, I would get to the next minimum and I would say, okay, how far did I go? That is the length of the period. Well, it's a little bit tricky, but again, you don't have to like sit there and like super like figure out what these numbers are. You guys notice, okay, if this is pi over 2, we started actually on a pi over 4. I am 1 pi over 4 to the left of starting at my y-axis. And look at where I finished. Between those, that is 1 pi, this distance right here is also pi over half of those, and 1 pi over 4 away from getting to 2 pi. So it basically took my graph and shifted it pi over 4 to the left. The period on this is still 2 pi. But it's the period again, how long did it take me to get from a minimum to the next minimum? 2 pi. Sometimes it takes a little bit of some algebra here, and you might have to sit there and count. Not very often. You don't see them this ugly very often. Questions? Okay. Again, it's always easiest if something's starting at the y-axis to utilize that to count, but you don't have to. Okay, so finding the period of the graph we were already working with. Going back to the one we were trying to write the equation of. We already know A and B, which will apply to both cosine and sine. The period will also apply to both cosine and sine. And so what I would do is, again, where is it starting at my y-axis? If I draw in my midline and I put the dot on the y-axis, you see how it starts at my midline? I would, to find the period of this one, count the sine curve, right? So we're starting at our midline, which means I need to hit a maximum, hit a minimum, and get back to the midline. And when I do that, see where that happens? That is the period. So the period is pi. Now we are writing equations today. We don't want the period. We always will be given what we don't want. Okay, and from the picture we get the period. B is 2 pi divided by the period, which is where a 1 full sine curve or 1 full cosine curve, how long it took me to do that. So in this situation, that was pi. Therefore, when I go to write my equation, I will find B by taking 2 pi divided by the period. And our specific B for this equation is 2. We have now completed the 3 letters that apply to both A, D, and B. Once I have done that, I have those 3 numbers for both of my equations. I don't have to redo that work when I go to write the second equation. The thing that is unique between our 2 graphs is going to be the phase shift, which we may or may not have to talk about yet. Okay, so putting it all together. Off to the side, I would have probably listed that for myself. My amplitude was 3. We just got a B value of 2 and a D value of -2. C is specific to our graph, and that is where my starting dot is. If I force you to write this as a sine curve, I would need to find a dot on my midline. Starts at the midline. Right? So we have 1, 2, 3, 4, 5, 6, 7 in this picture alone of the different dots that we could start assigning for that. If one of them happens to be on our y-axis, I would pick that. Okay? So I am going to, of those 7 options that I just highlighted, because all of those would start a sine curve, any dots on my midline, I'm going to use this one right now. Okay, so if I use that to start with, what would be our phase shift? 0, right? I have not moved right or left at all. So I would have a phase shift of 0, and that's why I would pick that one if I can. Okay? And the last thing we need to pay attention to is, okay, if I don't move right or left at all, is it a normal sine curve? Do I go over 1, up 1 for my next move? Or over 1, up our amplitude? Yep, I go up 1. So that is a normal sine curve from here, which means no ROX. So write my equation. Y equals. Fill in the letters in the appropriate spots. So we have an amplitude of 3. We are writing this as a sine curve because we picked a dot that started on our midline. I have a B value of 2. I do not have a C value, which means you do not need double parentheses. If we have both a B and a C, you must have double parentheses. If you have only one or the other, you do not need double parentheses. And finally, our B value is 2. Question. Okay. What if I force you to write this as a cosine curve? So again, we've done the work. A, B, and D do not change, regardless of which type of equation I'm writing. The amplitude will stay as 3. The period length, the amount of time it takes me to complete a curve, will stay as 2. Or B will be 2, the period is pi. Our vertical shift, again, does not change, but what changes again is our C value, and that is specific to where we start each equation. You have options. I would probably pick the one closest to our y-axis just to not have to count as far away. And if I have the option, I would pick a maximum because this cosine curve starts at a max or a min, if there's an ROA, right? So find a maximum to start our equation at. And what I now need to do is say, okay, where is that? Because that's going to be my C value, right? This one's a little trickier. How far to the right do we have to move to get to that, even with that dot? Over 4. Over 4. This right here would represent half of the next tick mark, and this is halfway between those. These are always evenly spaced. Okay. So if it is not on the tick mark, it is halfway between that and the next tick mark, always. Okay. We'll talk about that when we get there. So pi over 4. Now, this is one option. You could have picked 1, 2, 3 different maximums to start this out, and they're all correct. Okay, and that's where it's going to be a little bit tricky on our answer sheet because I picked one of them for us. You could pick any of them. Yes. Or a minimum. Yep, and you're like 2 pages ahead of me here. Yep, absolutely. Or you could have picked any of those 3 minimums. Okay, so 6 different options in one picture here. All are correct. Okay, writing our equation then. Because y equals, and again, A, B, and D are the same we just saw. But because we have both of these, you must have double parentheses. Okay, so I go write this equation, 3 cosine, and because I have both A, B, and the C value, you must separate them with double parentheses. 2 for the B value, and then X, we move to the right, so minus. Pi over 4. Down 2. Double parentheses because we have a B and a C. All right. What questions do you have for me so far? Okay. We're going to go back to what Logan was just talking about. What if I force you to start in a different place? Just so we don't have to work through all of those things again, we've already figured out A, B, and D. That is not changing. We're sticking with the same picture here. So A, B, and D we already have. If I force us to start at that dot we see in the picture, what does that change? There are 2 things that change. What is one of the things that changes? An ROX. Hey, Brady, how did you know that was an ROX? Yeah, you have it down first, right? So from this dot, our first moves the head down, and this is a sign for that indicates an ROX. Okay, what else does it change about my equation if I force us to start at that dot? C. Changes our C value. Okay, so that dot is even with what on our x-axis? What is our shift here? Okay, so this is the first time we're seeing putting this into our equation. It's going to show up as a negative, right? So if I'm having down push for a sine curve, when I go to write my equation, I need to make sure to put a negative in front of my amplitude to indicate that ROX. So we come down first from where we started. My amplitude is 3. We are doing a sine curve because we started at our midline. We have both a B and a C value, which means we need those double parentheses, right? We move right. So again, this would be a negative. And -2 for the down 2. All right. Questions? So very similar to things we've done previously. The only thing that I'm really adding in today is forcing you to write it as both equations, and so that adds in the phase shift. And we kind of avoided all phase shifts before. So now you can't avoid it if you have to write. Okay, last one with the same picture. And again, I'm forcing us to start with this dot right here. So first of all, sine or cosine, if I force us to start here. Cosine, because it's a minimum. What else does that mean? It's an ROX. Okay, so let's think our AB. Well, we don't have to think of our A, B, C, and D. A, B, and D are set for us. That will never change, regardless of where you start and what you call it on the entire picture. It's that C value that changes, and the fact that this is an ROX. We are at a minimum. Okay, this one's a little tricky. What is the phase shift on that one? It's a tricky one. So let's look at this real quick. It took me until pi to get to the end of my graph, right? So if on my x-axis we go out to pi, half of that would be pi over 2. Each of these parts would be taking the period divided by 4, right? If I broke it into 4 equal parts, or half of pi over 2, whichever way is easier for you to think about. Half of pi over 2 is pi over 4. Which means actually each of these is 1/4, right? 1/4, 2/4. Simplifies pi over 2. So the next one would be 3/4. 3 pi over 4. Again, we don't normally write that on there, but when I'm looking at a phase shift, I might have to kind of step back and say, okay, what would each of those two parts actually be, and add them up to where I'm at. Okay, so my phase shift on this one would have to be to the right. 3 pi over 4. Put all that into my equation. Don't forget the ROX. You started at a minimum. We have both a B and a C value. So I'm going to put those double parentheses in there. We move to the right, so it is minus 3 pi over 4, and then minus 2 pi over 4. Okay. How are we doing? We're going to pause there and let you try the beginning to end process of identifying for your picture A, B, C, and D, and writing both a sine and a cosine curve. This is what your worksheet looks like today. Okay, is that you are given a picture and you are given 2 lines. One of those lines is reserved for sine, one is reserved for cosine. I don't know the order that you find them. So think through your A, B, C's, and D's for each of those. Don't worry about the calculator. What do you guys are working on? Remember, you can do your A, B, C, and D. I'm going to grab my calculator to show you how to be able to check your equation. C is going to be so like what was the trading quarter? I would use it for my first contact and it applies. Same thing. Oh, so I'm just confused. So it depends on which equation you're writing, and that's when you would proceed. So, like, are you going to write it as a sine curve or a cosine? Cosine, okay. So would find a maximum or a minimum that you would like to serve. Okay, that's where we're going to get. So where is that magic? So I think the right will match the direction you move. So if you move to the right, positive pi would be right. I don't like busy, so I like sign here. So I'm based on minimum. No, not right to the midpoint. It could be a line or two. And so that's starting out. Yes. And then did I do grade 2? I believe this one is actually 1 because to get from that maximum to a maximum, it takes that last part of the so when it comes to same distance, because it starts at negative pi and ends at positive pi, that distance is 2 pi. And B is 2 pi divided by however we're just trying to figure out like a, okay, B means, B means under A and B should be, I just, okay. B means about, right? Because I'm going so then I say, okay, how long does it take to get back to a maximum? And the margin of it goes across, that's going to be part of it. So it should be until 2 pi to the period. A should have been the same. And then I think how do you think? And C is going to be specific to each of the 2 lines you're writing. So for cosine, I would decide which max or min I want to come in. You have one that's actually and yeah, I need to the side, I need to find which of the dots on my midline I want to use for my equation. And then wherever that's located, yeah. Yeah, so like that maybe I put in a slot, that would be a starting point, and that would put it to the right. Okay, so that would be your patient. Now, because from that becomes down first, you have right there. Okay. Guys, we have some things to talk through on this one. There are a lot of things to talk through on this one. Remember my suggestion, the first thing I'm going to do is draw the midline, right? It helps visually. So I'm going to find that location in here that is evenly spaced above and below. Okay, for my equations, A, B, and D will all be the same number for sine and for cosine. It is C that becomes specific to the equation that I'm writing. Okay, so A, how far is my maximum from my midline or my minimum from my midline? And that would be a distance of 2. Remember that that number is always positive. I'm going to go to D next because it's kind of the same topic. I drew my midline at -1. That's your vertical shift. -1. Okay. B. This one always throws people out. Again, it does not matter what you are writing it as. Pick what is going to be easiest, but you must complete one curve. And whether that one curve is a sine or cosine doesn't matter. But how long does it take you to complete one curve? And so in this picture, I would say, because starting at my y-axis, I'm starting at a maximum, it is going to be easiest for me to just trace one cosine curve and trace one cosine curve and let's return to a maximum. So from a maximum, I hit the bottom, I get back. That right there is one full cosine curve. How long did it take me? It took me until this tick mark. Based on the numbering, I got as high divided by the period. In this case, that would be 2 pi divided by 2 pi. Well, 2 pi divided by 2 pi is 1. Now, what if I use a sine curve instead of a cosine curve? Would I get a different answer? Okay, it does not matter. If I went from where a sine curve started, hits the maximum, hits the minimum, returns, that is 1, 2, 3, 4 tick marks, and 1, 2, 3, 4 tick marks along my graph means a distance of 2 pi. And it's the same conversation. Because it took me a distance of 2 pi to finish that curve. Okay, so however you're going to do that, I think it's easiest to start at your y-axis because then where you stop is the period, which is why I in this picture would have counted it cosine curve. Okay, any questions on those 3 numbers before we move on? Because now it becomes specific to my equation. I'm going to start talking about cosine first on this one. You have 1, 2, 3, 4, 5 different options of where you could have written this, which means for my cosine curve alone, I could have 5 different answers that are all correct. Okay? If it was me, I would pick this one because it does not move right or left at all. And I like to write mine without a phase shift if possible. It does not matter. You can always add a phase shift, that's fine. But I would have picked a C value of 0. If I picked this one right here, that means I would have moved to the left 2 pi. So my phase shift would have been negative 2 pi. Or to the right 2 pi. You could pick any of those maximums. If you wrote yours as a minimum, my phase shift here would have been negative pi. And I would have needed to list it as an ROS, or I would have needed to put a negative in my equation. Here, my phase shift would have been to the right pi, and again, starting at a minimum means I would have had a negative in my equation. So let's go write our cosine equation. I'm going to use this guy. Okay, phase shift of 0, amplitude of 2, cosine because I'm starting at a maximum. B value of 1, C value of 0 because I'm just not next to it, right? The right one is. Oh, that is 1, right? And then vertical shift is down 1. Because I don't have A, B, or C, if you did not put parentheses at all, it's also correct. Okay. Does anyone want me to write a different cosine curve than what's like with the phase shift? Like maybe this phase shift right here, if I had started here, that would have looked very similarly to where I would have an ROS. I would have moved to the left, okay, down 1. Also correct. Okay. Okay, so let's do a sine curve. A sine curve, I have 1, 2, 3, 4 options in this picture of which I could have correctly picked to write my sine curve. The phase shifts that would go with each of those would be, let's see, each of these represents a pi over 2. So that would be 1 pi over 2, 2 pi over 2, 3 pi over 2, negative, because we have less. So this one would have been at negative 3 pi over 2. This one would have been at negative pi over 2. This one would have been at pi over 2. And this one would have been at 3 pi over 2. Sine's a little trickier on the ROX part of it. You have to pay attention to which direction we head. Anytime we head down first, we would also have to include an ROX in my equation. So head down first, include an ROX in my equation. Pick one of those to write your equation. I'm going to go with this one. Negative pi over 2 left, pi over 2. My equation, again, the first numbers, A, B, and D do not change. A is 2. I'm writing it as a sine curve because I'm starting at my midline. I do have a phase shift in this one to the left, pi over 2, down 1. Any questions for me? Okay, again, things that will not change. A will be the same for both of the equations. B will be the same for both of the equations. D will be the same for both of the equations. That will not change. What will be different between the two equations is the phase shift and whether or not you have an RMS. The last thing we need to touch on very quickly here is what if you have a weird period? And I'm showing you this because you have one in your assignment that is tricky like this. Okay, I am supposed to go like from a, so this one's at my midline, I would count a sine curve. Well, a sine curve would hit a maximum, hit a minimum, and get back to a maximum, or get back to the midline. I have no idea what number that is because it is like not even halfway between my tick marks, right? So here's your technique. If you have something super bizarre like this, so the next time you're gonna have something super bizarre like this, okay? And this is what it is. Keep counting full curves until you get to a nice number. So there's another sine curve. Did that next sine curve end in a nice number? No. So do another one. Here's another sine curve. Did this one that I just drew end in a nice number? No. Do another one. Did this one end in a nice number? No. Do another one. Does this one end in a nice number? Yes. Okay, so when we do this, okay, so how am I going to figure that out? The period will equal the nice number. Write this in whatever's going to make sense to you. The nice number we ended at divided by the number of curves we traced to get there. So the nice number we ended at was pi over 2 in this example. I'm sorry, 2 pi. And it took me 1, 2, 3, 4, 5 curves to get there. So your ugly period length on this one is 2 pi over 5. Two things that I want to also help you with on this one. Okay, well, if the period is 2 pi over 5, remember B is 2 pi divided by the period multiplied by the reciprocal. Your 2 pi's cancel, and your answer would be 5 for a B value. And then the last thing I want to help you with is we're going to zoom in a little bit on this. Okay, so if, make this bigger, the period is 2 pi over 5, meaning I count that last tick mark as 2 pi over 5. Half of that, if this is 2 pi over 5, what's half of that? 1 pi over 5. If I forget that, I can always step off to the side and do my algebra to divide by 2, right? Divide by half. But what we might need is our phase shift is we might need to know what each of these tick marks, so what if my phase shift is right here? Okay, well, what's half of pi over 5? Over 10. Remember, when we're going half, the denominator seems to go the wrong way, right? Half of pi over 5 is pi over 10, which means every tick mark represents pi over 10. 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. Okay, that's tough. So hopefully that will help you through that. You're the one that you're going to run into on the worksheet. All right. Your assignment tonight is a worksheet, and again, your worksheet is it's going to be tricky to check the answer key because you may not pick the same phase shift that I chose to pick when I did my answer keys. If you are concerned about whether or not one of them is correct, I am happy to look at all